Read this question. Find equivalent resistance. Find equivalent resistance with respect to A and B. Find equivalent resistance with respect to A and B. Find equivalent resistance with respect to A and the B. All of you copied na figure? Okay, Jindal, I'll inform the technical team. Jindal, yesterday I already concluded I directly proportional Vs. That is the first statement. Then after V directly proportional to I. Okay. Both are the correct statement, Jindal. Okay. Yesterday I discussed one bridge problem. I hope all of you remember this one. Yesterday I discussed one bridge problem. Yesterday I concluded some points. The same figure we can read like this. What we concluded for the balanced bridge. For the balanced bridge, potential at point B and point D both are exactly equal. जब इक्विपोटेंशियल है तो प्रॉब्लम वी कैन सॉल्व बाय यूजिंग टू मेथड्स. एक मेथड क्या है जी, करंट जीरो बोल तो कैसे इंडिकेट कर सकते हैं इधर, ओपन सर्किट. और एक मेथड क्या है इधर, जब दोनों का पोटेंशियल सेम है तो वी इंडिकेट दैट वन एज ए शॉर्ट सर्किट. देखिए इधर बी एंड डी शॉर्ट सर्किट कर दिया तो बी एंड डी पॉइंट्स को जोड़ सकते ना, इधर बी एंड डी पॉइंट को जोड़ सकते ना. कैन इंडिकेट वन सिंगल पॉइंट. While solving the problem, आप इधर ओपन सर्किट प्रेफर कर सकते हैं ना, इधर शॉर्ट सर्किट प्रेफर कर सकते हैं. You can use any method. To solve that Q problem also, I am going for this approach. जिधर पोटेंशियल सेम रहते, we can join those 2 points. Wherever the equipotentials are present, we can join those 2 points. Now for this example, what is the requirement? The equivalent resistance with respect to A and the B. Now give the any names here. Give the names as C, D. Can I indicate like this? Now concentrate on this A, B, C, D points. Concentrate on the A, B, C, D points. Like either R, and R. Now indirectly balance bridge condition satisfied. Yesterday I concluded one point. Bridge means 2 diagonal points are the present. In this example A to B, this A to B is a one diagonal point. This C to D is a other diagonal point. Here the A to B is one diagonal point. Wherever we need the equivalent resistance, simply assume as a with respect to AB one source exists. जिधर आपको इक्विवेलेंट रेजिस्टेंस चाहिए, जस्ट इनडायरेक्टली इमेजिन एज ए टू बी वन सोर्स एग्जिस्ट. इधर और एक डायगोनल पॉइंट के इधर सी एंड द डी. जस्ट नाउ कंक्लूडेड, जब ब्रिज कंडीशन सेटिस्फाई हुआ तो पोटेंशियल एट पॉइंट सी, पोटेंशियल एट पॉइंट डी बोथ आर एग्जैक्टली इक्वल, इक्वी पोटेंशियल पॉइंट्स. जब इक्वी पोटेंशियल पॉइंट्स है तो प्रॉब्लम सॉल्व करने के लिए वी कैन गो फॉर 2 अप्रोचेस. एक अप्रोच क्या है, सी एंड डी आर दी ओपन सर्किटेड, और एक अप्रोच क्या है इधर, शॉर्ट सर्किट. Now to solve this problem, you can go for so many approaches. I am going for short circuit method. देखिए that C and D points. For the C and D points, we can indicate the common point. Can you redraw the simplified figure for this one? A, A2 one is going to C, other one going to the D. For C and D indicate one common point. Now A2 one more element is going to the G. What about other one is the B is also going to the C, this B is also going to the D. The B is going to the C and B is going to the D. C and D are the same potential. Same potential means I indicate one common point. I hope everything clear now, this audio, video. Okay. Regarding yesterday's lecture, I already informed technical team. Don't worry. Very soon the team will be upload that video. Okay जी, don't worry. अब देखिए इधर, this C and D दोनों का potential same है ना. देखिए इधर, elements in this one both are exactly identical. जब सब identical हुआ तो जो प्रेशर C and D को लगा रहे exactly same concept इधर भी लग सकते हैं. जो कॉन्सेप्ट C एंड D को अप्लाई कर रहे हैं सेम कॉन्सेप्ट कैन अप्लाई फॉर E एंड द F. देखिए इधर C एंड D के लिए वी इंडिकेट वन कॉमन पॉइंट, E एंड F के लिए भी वी कैन अप्लाई द सेम लॉजिक. सेम लॉजिक क्यों लगा रहा बोले तो एलिमेंट्स इन द अपर वन एंड लोअर वन बोथ आर एग्जैक्टली आइडेंटिकल. दैट्स व्हाई हियर दिस E एंड F. देखिए इधर फ्रॉम दिस पॉइंट टू वन इज गोइंग टू E, अदर वन गोइंग टू द F. इधर E and F के लिए we can indicate one common point. Now similarly here also from this point also one is going to E, other one going to the F. Come to the other one. Come to C and the E. देखिए इधर C to E one more element R, and other one is a D to F is a one more element R. The same figure to conclude easy way I developed like this. Simply which application I utilized here? Equipotential concept. जिधर equipotential है yesterday concluded we can go for the two approaches. एक approach क्या है open circuit और एक approach क्या है short circuit. सर कौन सा मेथड लगा रहे short circuit. The given figure को we develop like this. The given figure we develop like this. अब simplify करेंगे. देखिए in this example ऐसा बोल सकते हैं ना, these two are currently the parallel. देखिए these two also parallel. देखिए these two also parallel. Now these two also parallel. इधर for each parallel combination के लिए can you indicate respect to equivalent resistance? Each parallel combination के लिए can you indicate respect to equivalent resistance? In this example, what is our requirement? The equivalent resistance with respect to A and the B. देखिए इधर R both are in the parallel. क्या बोल सकते हैं इधर R/2. इधर भी R both are in the parallel. Equivalent value is R/2. R/2. For each parallel combination, देखिए for each parallel combination we get the equivalent resistance. Finally क्या चाहिए आपको? Equivalent resistance with respect to A and the B. हमेशा एक स्टेटमेंट याद रख लो आप, जिधर आपको equivalent resistance चाहिए, we should not disturb those 2 points. Now remaining points can be eliminated. Remaining points होना बोल तो eliminate कर सकते इधर A and B points को disturb नहीं करना इधर. आप इधर A and B points को disturb नहीं कर रहे हैं, then can you conclude here how this R/2 and R both are connected in the series. इधर पे देखिए R/2 and R both are connected in the series. First draw the figure up to this one. I'll continue. कौन है? खुशबू. A and B जिधर आपको equivalent resistance चाहिए, for that one we have to connect one source. Yesterday I concluded, भूल गया क्या? Yesterday discussed on bridge problem. What I concluded there, in one diagonal point source is a present, other diagonal point is a short circuited. One diagonal point source is a present, other diagonal point is short circuited. आप बोल रहे ए एंड सी ऑल्सो शॉर्ट सर्किटेड, वो कैसा होता है? बैलेंस ब्रिज बोले तो वन डायगोनल पॉइंट, ब्रिज में दो डायगोनल पॉइंट्स रहते हैं. देखिए एग्जांपल में दिस इज वन डायगोनल पॉइंट, दिस इज अदर डायगोनल पॉइंट. एक डायगोनल पॉइंट में सोर्स और एक डायगोनल पॉइंट इज अ शॉर्ट सर्किटेड. फॉर दिस पर्टिकुलर एग्जांपल वी आर यूजिंग एप्लीकेशन ऑफ शॉर्ट सर्किट. ओके, इक्वी पोटेंशियल कॉन्सेप्ट वी आर अप्लाइंग. क्यों बोलते सबका रेजिस्टेंस सेम है ना. ए बी बीच में आपको इक्विवेलेंट रेजिस्टेंस चाहिए. सिंपली एज्यूम एज ए बी बीच में कुछ सोर्स है. अदर डायगोनल पॉइंट्स क्या है? सी एंड डी. सी एंड डी को शॉर्ट सर्किट लगा रहे हो इधर. शॉर्ट सर्किट बोलते सी एंड डी पॉइंट्स को जोड़ सकते हैं इधर. ओके, फर्स्ट नोट ऑन दिस वन. Okay, now let us simplify further. For this example, देखिए R by 2 both are contained in the series. R by 2 both are in series. These two are in series 3R by 2. It is also 3R by 2. Now finally, what is the requirement? Equivalent resistance with respect A and the B. Equivalent resistance with respect A and B. Again carefully observe. देखिए, if I name this as Z1, Z2, Z3, Z4. Carefully observe there. In this example also, simplification करने के बाद इधर भी क्या हो रहा है जी? बैलेंस ब्रिज कंडीशन सेटिस्फाइंग. इधर भी क्या हो रहा है? बैलेंस ब्रिज कंडीशन सेटिस्फाइंग. Whenever it is satisfying balance bridge condition, we can go for the two approaches. इधर दो मेथड लगा सकते हैं आप. वन मेथड क्या है इधर? नो, वन पॉसिबिलिटी इज वी कैन ओपन सर्किट दिस ब्रांच. क्या बोलते हो? whenever it is satisfying here, indirectly we can say potential at this point, potential at this point both are exactly equal. आपको क्या चाहिए? equivalent resistance with respect A and the B. A and B में just assume as one source is present. Now this is other diagonal point. इसमें करंट कितना जाता है इधर? 0. क्यों बोले तो बैलेंस ब्रिज. इधर प्रॉब्लम सॉल्व करने के लिए वी कैन गो फॉर एनी अप्रोच. होना बोले तो आप शॉर्ट सर्किट कर सकते हैं, ना तो ओपन सर्किट कर सकते हैं. ओके, हियर आई एम गोइंग फॉर द ओपन सर्किट. होना बोले तो आप शॉर्ट सर्किट भी कर लो, चेक करो, आंसर विल गेट द सेम आंसर. आंसर कुछ भी डिफरेंस नहीं होता इधर. इन दिस एग्जाम्पल हियर इफ आई ओपन सर्किट दैट ब्रांच, in this example if I open circuit this branch, what we get? R by 2. you can indicate like this. What is the requirement of the equivalent resistance with respect to A and the B? For that one, can you conclude here how this R by 2 both are connected? Series. How this 3R by 2 and 3R by 2 both are connected? Series. Can you develop the simplified figure for this one? Can you develop the simplified figure? If you develop the simplified figure, finally, क्या चाहिए आपको? इक्विवेलेंट रेजिस्टेंस विथ रेस्पेक्ट ए एंड द बी. देखिए दोनों वैल्यू एलिमेंट्स को जोड़ दिया तो इक्विवेलेंट रेजिस्टेंस कितना इधर R, इधर भी 3R by 2 3R by 2 दोनों जोड़ दिया तो इक्विवेलेंट कितना इधर 3R. देखिए इधर फाइनली हाउ दिस R and 3R, how this R and 3R both are connected in the parallel. R 3R both are connected in the parallel. If two resistors are in the parallel, equivalent resistance. Equivalent resistance, can I write this set? Then what is the answer? 3R by 4. What is the answer? 3R by 4. जिधर आपको इक्विवेलेंट रेजिस्टेंस चाहिए ऐश्वर्या, जिधर आपको इक्विवेलेंट रेजिस्टेंस चाहिए अक्रॉस दोस टू टर्मिनल्स इनडायरेक्टली ऑलवेज रिमेंबर एज ए वन सोर्स एग्जिस्ट, ऐसा सोच के प्रॉब्लम सॉल्व करना है. हाँ यस विकास कुमार, एनी क्वेश्चन अप्लाई कर सकते जी विकास कुमार. Okay. And one more thing, dear students, again while doing the revision, don't spend much time on the connections and all these things. While doing the revision, simply remember as a, in the cube, remember respect to AB points. Remember the respect to AB points and final answer. Respect to AB points and final answer. क्यों बोलते हो? All these are the standard questions. With respect to competitive exams, all these are the standard questions. Only आपको to get the idea about the connection, I explained all the steps. मगर revision करते समय don't spend much time on the connections. Mainly focus on the respect to AB points and finally equivalent resistance. 3R by 4. Very good, very good. Okay, चलिए come to the one more example. That is one more question. Find equivalent resistance. Find equivalent resistance. Find equivalent resistance with respect to A and B. Find equivalent resistance with respect to A and B. Draw this figure. Find equivalent resistance with respect to A and B. Millie John, your doubt will be clarified in this problem. Don't worry. कौन है श्रुति? In the first class itself like concluded, अपना network analysis में ये problem solve करने के लिए so many methods are there. In that one I explained one of the method. मगर आप कोई भी method लगाना है मगर answer same आना है. Okay? You can go for any approach. Okay? Jindal, just now I concluded so many multiple methods can be applied मगर answer same आना है. Same आना ही आ रहा बोलो तो कुछ गड़बड़ है आपका मेथड में. ओके, hundreds of methods are there to solve these Q problems. In that one I explained one of the method. Okay, Millie John, your doubt will be clarified in this problem. Don't worry. खुशी शर्मा, कुछ गड़बड़ किया होगा कैलकुलेशन में, शॉर्ट सर्किट से भी आते हैं जी, कुछ गड़बड़ किया होगा, आप चेक कर लो एक बार. 100% सेम आते हैं. ओके, नाउ ऑब्जर्व है. नाउ इन दिस पर्टिकुलर एग्जांपल इधर देखिए. If you are looking at the AB points here, upper section and lower section both are exactly identical. If you are looking at the AB points, this upper network and lower network both are exactly identical. Symmetry is satisfying. आप इधर AB points से देखें तो upper one and lower one both are exactly identical. Symmetry is satisfying. जब symmetry satisfy हुआ तो with respect to AB points, assume one source. Let us assume voltage source is Vs. Let us assume it is delivering a current of the I. With respect to AB points, this upper one and lower one both are exactly identical. Symmetry is satisfying. जब symmetry satisfy हुआ तो assume one voltage source. Let us assume it is delivering a current of the I. I current is reaching at this point. देखिए, after reaching at this point, how many branches are there? Branch 1, branch 2, branch 3. 3 branches are there. All the 3 branches have the equal value of the resistances. Then what is the current of each branch? Current of each branch is the I by 3. Now current of each branch is a I by 3. Now then after carefully observe here, I by 3 current is coming here, it distributed the 2 branches. Then what is the current of this one? I by 6. What is the current of this one is the I by 6. Then here in this example, I by 3 current is coming here, it distributed between the 2 branches. I by 6, it is also I by 6. Again observe carefully. This I by 6 coming, what is current of this one? How much here? I by 3. Current of this one is I by 3. Then for this particular example, give the any names. Give some K, give some name as a P. Now for this particular example, for this AK, PBA. Now for this entire portion, write the KVL equation. For this entire portion, write the KVL equation. आप इधर KVL equation होना बोल तो we can write for the bottom part of the network or top of the network. किधर भी लिख सकते हैं आप. You can write the KVL equation either for the lower part or in the upper part. You can write the KVL equation either lower part in the upper part. Anywhere you can write the KVL equation. देखिए in this entire portion source वोल्टेज कितना इधर Vs. इधर source वोल्टेज कितना इधर Vs. Now source voltage Vs. अब देखिए इधर A2K करंट कितना इधर I by 3, रेजिस्टेंस इधर R. Now from K to P करंट कितना इधर I by 6, रेजिस्टेंस इधर R. Now similarly P to B, what current is I by 3, resistance is R. Resistance is R. For this entire portion, can you write the KVL equation? If you write the KVL equation for this one, by simplify करने से check करो जी, you can write this V by I equal to 5 by 6 R. 5/6 R. That means इधर देखिए with respect to AB points source वोल्टेज कितना है इधर Vs, करंट कितना है इधर I. That V by I ratio, this V by I ratio indicate the resistance with respect to A and the B. That V by I ratio indicate the resistance with respect to A and the B. Ratios with respect to A and the B. Now observe here. We'll get one common doubt. We'll get the common doubt as the method what we applied here. The method what we applied here, we assume one voltage source. Why don't you apply this method for previous problem? You get the doubt as why don't you apply this approach for the previous problem? देखिए for previous problem को this method cannot be applied. Reason क्या है बोले तो देखिए इधर in this particular example, we need the equivalent resistance with respect to A and B. If you put your hand here across this A and B, top side we can view only these two resistors, but bottom side you can observe this entire network. इधर with respect to A and B पॉइंट से सिमिट्री डिफाइन नहीं कर सकते, इधर सिमिट्री डिफाइन नहीं कर सकते. But if you come to our previous problem, if you observe this problem, with respect to A and B, we can say upper portion, lower portion both are exactly identical. जिधर आपको equalization चाहिए with respect to those 2 points, if network is exactly identical, symmetry is satisfying, then only we can go for this approach. But previous problem, that statement is not satisfying. That's why here the previous problem, this KVL concept cannot be applied. I hope previously some of the students asked doubt about this one. I hope your doubt is clarified now. Okay. Yes, Bhavana. All the resistors are having the equal values now, R and R and R. As well as symmetry also satisfying. Yes, Bhavana, your statement correct. Okay, very good, Swati Verma. Okay. इधर एनीवेयर यू कैन राइट केवीएल इक्वेशन. आप केवीएल इक्वेशन होला बोल तो बॉटम कर सकते हैं, नहीं तो टॉप भी कर सकते हैं. एनीवेयर यू कैन राइट केवीएल इक्वेशन. इन दिस एग्जांपल वी आर गोइंग फ्रॉम A to K, K to P, P to B. फाइनली B to it reaches to A. होना बोल तो आप टॉप भी लिख सकते हैं. आप एनीवेयर यू कैन राइट. चॉइस इज योर्स. Okay, चलिए. Now same problem we can solve by using other approach. चलो check करेंगे what is that other approach for this one. Let us see what is the other approach for this one. You can give the A names here. Now give the names as some G. You can give the any names. Now for this particular example, थोड़ा ध्यान से देखिए इधर. I/3 is coming here. This I/3 current distributed as A. Then what is current this one? How much? I/6. ये भी current कितना इधर? I/6. For this example, I/6 coming. What is current this one? How much? I/3. Current is I/3. I/6 coming. What is current is how much here? I/3. It will be same thing. I by 6 coming, I by 6 coming. But the current is on how much here? I by 3. Now current of the each branch is obtained. Current of each branch is obtained. Now for this particular example, क्या चाहिए आपको? Equivalent resistance with respect to A and the B. Particular example, equivalent resistance with respect to A and the B. Now let's check it out. Carefully observe. Shall I say like this, sir? Potential at point G, potential at point K, potential at point S, all are same or different? देखो जी, at point G, point S and point K, potentials are same or different? A to G, A to S and A to K, all the potentials are the same. क्यों बोलते हो? In this example here, for all the branches, what the current is the same, resistance also same. Current is the same and resistance also same. Then here potential at point G. For this example, potential at point G and point S and point K, all are the same. Whenever the potentials are same, one approach is we can join the respective equipotential points. We can join all the respective equipotential points. Then here the same figure. The same figure, we can draw this one as a A. Now in this example, one is going to the G. What about other one is going to the S? What about one more terminal going to the K? All are having the same potential. Same potential means, can you join all the respective points? Can you join all the respective points? Similarly, come to the point B. Point B also देखिए, B to T and B to P and B to F. ध्यान से देखिए, B to T and B to P and B to F, सबका पोटेंशियल सेम ही है. रीजन क्या है बोलते हो? सबका करंट इज सेम. I/3 रेजिस्टेंस R, इधर भी I/3 रेजिस्टेंस R. Whenever the current is same, resistance is also same, we can say potential difference B and T, this B and F, B and P are the same. सबका potential is also same. Then here the same figure. सबका potentials are the same. Now what are the respective points T? What about other one is the P? What are one more terminal is the F? For all the cases, potentials are same. Whenever the potentials are same, equipotentials are there, we can join all the respective equipotentials. We can join all the respective equipotentials. We can join all the respective equipotentials. Come to the G. In this example here, from point G here, now one is going to the T, one is going to the F. देखिए, T and F already connected together. From point G, we can indicate the two branches. Come to the S. Now in this particular example here, from S also it is going to the T, it is going to the P. Now T and P already connected together. Come to the K. From point K also, what is the one is going to the F, what is the one is going to the P. Now in this example, F and P already connected together. Now the same figure with help of the application equipotential concept. Same figure with help of the application equipotential concept, we can draw like this. For this example, how these three branches are connected in the panel. Now here also, how these three branches are connected in the panel. And in this example, how the 6 branches also connected in the panel. 6 branches also connected in the panel. Now what is the requirement? Equivalent resistance with respect to A and the B. equivalent resistance with respect to A and B. These three branches are in the parallel. What about equivalent resistance for this one? R by 3. This 6 branches are in the parallel. What is the equivalent resistance for this one? R by 6. इधर भी देखिए 3 branches are in the parallel. इधर भी equivalent resistance कितना है इधर? R by 3. आप सिंप्लीफाई कर सकते हैं ना? देखिए R by 3, R by 6, R by 3. If you find out the equivalent resistance, then what is the answer for this one? 5R by 6. 5R by 6. Okay. Source VAC is assumed, Sachin. To solve this problem, two methods are there. One is the KVL equation method, other one is the equipotential concept. Variations value different है तो नहीं कर सकते. कौन है बड़े मियाँ? Class is at 2 man, not 2:30. क्या आप assume किया क्या आप? Yesterday also announced class 2 to 5 बोल के. त्रिपाठी वोल्टेज को देखना है जी. इधर सब ब्रांचेस का करंट सेम है, रेजिस्टेंस सेम है ना. जब करंट सेम है, रेजिस्टेंस सेम है, तो वोल्टेज का फॉर्मूला क्या है? I into R. वोल्टेज भी सेम. ओके भावना, जस्ट आई एक्सप्लेन द टू मेथड्स. ओके हाँ, इधर भी डियर स्टूडेंट्स, जब रिवीजन करते समय डोंट स्पेंड मच टाइम ऑन दिस KVL इक्वेशंस एंड इक्विपोटेंशियल ऑल दिस थिंग्स. Only important point is the use your memory power. Remember respect to AB points and final answer. With respect to competitive exams, all these are the standard questions. जब रिवीजन करते समय ज़्यादा टाइम स्पेंड मत करिए पूरा कनेक्शंस आइडेंटिफाई करने के लिए. use your memory power. Remember respect to AB points and corresponding equivalent resistance. Okay. You can apply any method. Okay. Here remember as a corresponding cube. Try to remember the 3 answers. देखिए जब रिवीजन करते समय try to remember the 3 answers for this cube. Okay, these are the 3 possible questions corresponding cube. These are the 3 possible questions. Now for that one, this is one of the possible question. Already discussed the derivation for this one. What was the answer for this one? 3R by 4. Now, if AB points are present like this, equivalent resistance क्या इधर? We can write this as 5R by 6. Likewise, we can do one more derivation. Directly I am writing here. If A and B points are given like this. Now for this one, equivalent resistance is 7R by 12. 7R by 12. इधर एक स्टेटमेंट याद रख लो आप. जो प्रोसीजर रेजिस्टर के लिए लगा रहे, exactly same प्रोसीजर valid for the inductors. Same procedure valid for the impedances also. This procedure valid for the resistance, inductance and as well as the impedance. Capacitor के लिए simply we go for reciprocal value. मान लो in place of resistor capacitor given, simply write this as 6 by 5. Okay. Revision करते समय try to remember these final 3 answers. Already derivation done for the first question and the second question. Okay. For symmetry के लगा सकते जी. If all the ratios are unequal, directly this method cannot be applied. Now it becomes a conventional question. You have to go for the star delta transformation. It becomes very lengthy. Okay. Adarsh. Sumedha Vyas, I hope this is the 4th class, I think. Maybe this is the 4th one, I think. वीडियोस अपलोड होता है ना जी, चेक कर लो. वो भी डाउट है क्या? Try to ask the doubts related to subject only. Don't ask any other general doubts. If you have general doubts, at the end of the class, you ask me. Hey students, once again I am stressing, try to ask the doubts related to particular the topic which is going on. उसके बारे में बात करिए. जो आपका मन में general doubts है, at the end of the class you can ask me. Read the next question. Next question. Find equivalent resistance. Find equivalent resistance with respect to A and the B. Find equivalent resistance with respect to A and B. देखिए, these are the AB points. Somebody asking AB points किधर है? क्या नहीं दिख रहे जी? बड़े मियाँ? 7 ऑर्बिटल के लिए these are the AB points. AB points. Somebody asking AB points किधर है? कॉपी कर लो. Now find the equivalent resistance with respect to A and the B. Find equivalent resistance with respect to A and the B. Now corresponds example, carefully observe. Carefully observe. This entire portion corresponds to one section. This 1 entire portion corresponds to first section. And second section 1 second section, third section. Likewise, infinite number of sections are present. For this particular example here, this is the first section and second section, third section. Likewise, infinite number of sections are present. Infinite number of sections are present. Whenever the infinite number of sections are present, with respect to AB points, assume equivalent resistance. With respect to AB points, assume the equivalent resistance is the R input. Equivalent resistance is R input. Come to the point C and the D. Come to point C and the D. If you are looking at the point C and D, one section is excluded. If you are looking at the point C and D, one section is excluded. If one section excluded with respect to CD points, total how many sections are there? Infinite minus 1 sections are there. If you are looking at the point C and D, one section is excluded. One section excluded means infinite minus 1 sections. What is infinite minus 1 sections equal to approximately how many sections? Infinite. Infinite minus 1 equal to approximately how many sections again? Infinite. देखिए, with respect to AB points, total number of sections are infinite. कितना है जी? Equivalent value R input. आप इधर C and D से देखें तो भी इधर भी equivalent से कितना है? Approximately infinite. With respect to A and B, infinite sections के लिए what we assume would equivalent is R input. आप इधर C and D से देखें तो भी approximately infinite sections are there. Can you give the same name? Here also equivalent is R input. Equivalent is R input. Then here, can you draw the simplified figure for this one? Can you draw the simplified figure for this one? For this example, can you draw this figure like this? In this example, with respect to C and D, what is the equivalent value? How much here? R input. With respect to A and B, also, again, what is the equivalent value? Is the R input. Equivalent value is the R input. Can you simplify this figure now? Can you simplify this figure? For this example, how this one R input both are connected? Parallel. If you are looking at A and B, this 1 ohm, this parallel combination and 1 ohm, all are connected in series. with respect to A and B, 1 ohm, this parallel combination and 1 ohm, all are connected in the series. Can you find out the equivalent resistance for this one? Can you find out the respective equivalent resistance? प्लस 1 ऐसा लिख सकते हैं ना. देखिए, this parallel combination connected series to 1. This parallel combination connected series to 1. It will be same thing. Parallel combination connected series to 1. Parallel combination connected series to 1. Now, can you simplify further? चेक करो जी. कैन यू रीअरेंज दिस एक्सप्रेशन? Now for this quadratic equation, finally what you got here? You got one quadratic equation. Can you find roots for this one? Can you find roots for this one? चेक करो जी. पहले चेक करो, स्टेप्स चेक कर लो. Just verify the steps. Can you conclude the answer? Final answer. Oh, many students got the answers. Very good, very good, very good. Okay. चेक करो. Many students are giving answer as a 1 plus root 3. चेक करो जी एक बार. 1 plus root 3. yes, ऐश्वर्या, योर स्टेटमेंट करेक्ट. सेम पैटर्न रिपीट हो रहा है. आप ABC देखे तो जी कितना सेक्शंस आ गया? इन्फिनिट. इफ यू लुक फ्रॉम C and D also, approximately how many sections are there? Infinite. That's why I give the same name. ABC देखे तो R input, CDC देखे तो भी approximately R input. And one more thing, some students are asking doubt, 1 plus or minus root 3. मगर इधर प्लस ही कंसिडर करना है. क्यों बोलते हमेशा इक्विवेलेंट रेजिस्टेंस कैसे रहते हैं जी? पॉजिटिव. Always you should consider equivalent resistance as a positive. Consider only positive sign. Negative, don't say consider negative sign. क्यों बोलते equivalent resistance should be always positive. Consider only positive sign. Okay, Bhavana and Vikas Kumar. Very good, very good, very good, very good. I hope all of you got the answers. Observe here. Now for this model of questions, let us one more question. Otherwise, for the previous problem itself, first let us do the calculations. Okay. For this previous problem we can solve by using other approach. Now here we can go for this approach also. For this model of networks here, one standard formula is developed. Now this standard formula to find out the equivalent resistance. But whenever you are up in the standard formula, here the important point is it is a R1 and it is a R3 and it is a R2. Whenever you are applying standard formula, it is a R1, R3 and R2. That is important point. With respect to that one, either substitute कर सकते हैं आप, check करो जी, substitute करो a formula में. Now this standard formula to find out equivalent resistance. Praveen Saxena, yes, you are visible. Okay. If you are finding it difficult in the previous method, how now you can go for the standard formula. I hope it is visible now. Otherwise, shall I change the color for this one? Whenever you are applying this formula, this is one standard formula for this model of questions. This is one standard formula. Derivation सब कुछ आपको जरूरत नहीं है जी. Same thing. आप फिर क्वाड की इक्वेशन लिखे तो सिंप्लीफाई करते तो यही आते हैं आंसर आपको. In the previous case, what you have taken resistance values, you have taken 1, 1, 1. Instead of 1, 1, 1, take as some R1, R2, R3. फिर पूरा सिंप्लीफाई करने से finally you get general equation only. Okay? We are not applying any new concept here. Magar, whenever you are applying this formula, carefully give the names. This is R1, this is R2 and R3. Check karo ji, in this method also answers are same or different? Check karo ji, in this method also answer is the same. Okay? Try to apply this formula carefully. If you apply the previous papers to the GATE and ESC, same model with slight modifications repeated more than 5 times. The similar model given in the GATE and as well as the ESC with slight modifications. If you go for this formula, we can save the time in the exam. Oh, हिमांशु क्लास स्टार्ट हो गया जी. बड़े मियाँ हिमांशु जी क्लास चल रहे. विनायक कुमार previously already explained method 1 ना. For method 1 only पूरा derivation करे तो you get a simplified form of equation. Okay. Right. One more question. One more question. Find equivalent resistance. Find equivalent resistance. Find equivalent resistance with respect to A and B. Find equivalent resistance with respect to A and the B. Equivalent resistance with respect to A and B. Draw this figure. I did small modifications in this one. Then compared to previous one, I did small modifications. Find karo idhar. Find the equivalent resistance with respect to A and the B. Okay. Somebody requested in the previous slide. Copy kar lo ji. Somebody requesting this one. Check kar lo. Somebody requesting this one. Take it fast. Okay. Now here also, to solve this problem, we can go for two approaches. Previously I already explained method 1, method 2. Method 2 क्या है? Formula. Here I am solve the problem by using method 2. होना बोलते बाद में आप method 1 से भी चेक कर सकते हैं. Here भी चेक करो. Now this entire portion, the first section, now second section, third section, likewise infinite number of sections are present. Now I am going for this formula. But if you want to apply this formula, give the names very carefully. Give the names carefully. देखिए, in this example there is a R1, it is a R3, it is a R2. R2 equal to 0. Is the R1, is the R3 and the R2. R2 equal to कितना इधर? 0. Now can you substitute the respective values? The respective values put कर सकते हैं ना? Simplify करो. Simplify करने से can you find out the equivalent resistance with respect to A and B? चेक करो जी आप. होना बोलते बाद में आप मेथड 1 से भी चेक कर सकते हैं. चेक करो. Many students are giving answer 1 plus root 5 by 2. चेक करो. Is it correct? One plus root 5 by 2. Okay, very good, very good, very good. अगर give the names carefully, R1, R2, R3 का नाम थोड़ा ध्यान से दे दो इधर. Okay, चलिए, come to the next one. In the same model, in one of the previous papers, in one of the paper, it was given like this. In one of the previous papers, it was given like this. You ask you to find out the equivalent resistance. You ask you to find out the equivalent resistance. Give any names here. You ask you to find out the equivalent resistance with respect to X and the Y. Now, बोलिए कैसे कर सकते हैं? In one of the previous papers, it was given like this. Only first element was modified. Instead of 1 ohm, it was given as a 2 ohms. Remaining resistances are same. 1, 1, 1. Same sections are repeated. Same sections are repeated. बोलिए, how can you say answer easy way for this one? How can you find answer for this one? Okay. If same sections are repeated, then only we have to apply Chandrapal. Similar sections. If similar sections are there, then only we can apply this approach. R1, R2, R3 कोई भी value ले सकते हैं आप. If same sections are repeated, we can go. No issue. Okay. हाँ, देखिए, in this particular example, if कौन सा element अलग है जी? Only first element is different. First element is different. First element क्या है इधर? 2 ohms. The 2 ohms, can I split this one as a? Can I split like this? Corresponds example, the 2 ohm resistor, we can separate the 1 ohm and the 1 ohm. 1 ohm and the 1 ohm. Then here in this example, can you indicate these AB points like this? Can you indicate the AB points like this? Now for this example, देखिए जी, it is a first section, it is a second section. Likewise, infinite number of sections are present. Infinite number of sections are present. That means first try to conclude the answer. Equivalent resistance with respect to A and the B. Equivalent resistance with respect to A and B. Equivalent resistance with respect to X and the Y. देखिए with respect to A and B, with help of this formula, you can find out resistance. With help of this formula, just now we concluded what is the equivalent resistance with respect to A and B. We can write say 1 plus root 5 by 2. 1 plus root 5 by 2. This entire combination, देखिए this entire combination, this A and B and this 1 ohm, दोनों कैसा है जी? सीरीज. दोनों कैसा है जी? सीरीज. Then with respect to X and Y, what is the total resistance? 1 plus RAB. 1 plus RAB. Okay. That means the 2 ohm resistance we split as a 1 ohm and 1 ohm. Then after same procedure we are repeating. Okay. All of you clear this one? Okay, very good. Read the one more question. Read one more question. Find equivalent resistance. Find equivalent resistance with respect to A and B. Find equivalent resistance A and the B. Equivalent resistance with respect to A and B. Draw this figure. Now for this example, first you will get one common doubt. Common doubt क्या है बोले तो देखिए इधर with respect to AB terminals, upper one and lower one both are exactly identical. With respect to AB points, upper section, lower section both are exactly identical. First we will get common doubt as a here the symmetry condition satisfying, then you'll get doubt as a with respect to AB terminals, can you assume the voltage source? You'll get doubt as a can you assume the voltage source? Now you'll get doubt as a can we indicate this current as a I by 3 like this. Generally you'll get this doubt. अब बोलिए, is this method is a correct or the incorrect? Is this method is a correct or incorrect? सोचिए आप, सोच के give the reply. Can we apply this method or not? सोचिए, सोच के बोलिए आंसर. Can we apply that approach or not? चेक करो एक बार. Give the reply. Okay. क्यों बोलते previously we discussed one Q problem. In the Q problem what we did? With respect to AB terminals, assume voltage source Vs. It is delivering current to the I. This voltage source delivering current to the I. This I current, this example, this I current distributed as a I by 3 and I by 3. We indicate like this now. Can we apply this approach here? That is my question. Getting up previously for Q problem we divided equally. Okay. Okay. अब चेक करेंगे. Can we apply it or not? देखिए थोड़ा ध्यान से देखिए. This branch is connected to again further how many branches? 2 branches. इधर भी देखिए, this branch connected to further how many branches? 2 branches. इधर भी same thing. This branch connected to further how many branches? 2 branches. देखिए इधर भी 2 branches, इधर भी 2 branches, इधर भी 2 branches. मगर इधर देखिए. For this example, it is connected to how many branches here? 2 branches. मगर इधर देखिए, this branch connected how many branches? 1, 2, 3, 4, 5. It is connected how many branches here? 5 branches. मगर it is connected how many branches here? 2 branches. अब बोलिए connections are identical, not identical? Not identical. मगर इधर देखिए, it is connected to further how many branches here? 2 branches. Simply we can say current distributed as I by 6 and I by 6. दोनों branch connect हुआ इधर. इधर भी कितना branches है इधर? 2 branches. क्या बोल सकते हैं? Current is I by 6. I by 6. Here we can I by 3 coming here. We can write this as I by 6 and I by 6. Current is equally distributed. मगर इधर देखिए कनेक्शन कैसा है जी? This branch connect how many branches sir? 2 branches. देखिए it is connect how many branches sir? 1, 2, 3, 4, 5 branches. That means connections correspond. This one and this one are not identical. Not identical है तो directly this method cannot be applied. This method cannot be applied. Can you write the note with your own statements? क्यों बोलते many students get the common doubt. AB point से देखे तो upper one lower one both are exactly identical. Symmetry is satisfying. Then why don't you apply this approach? You'll get the doubt. Can you write the note with your own statements? क्यों अप्लाई नहीं करना है? Reason क्या है इधर? This resistor current how many branches? 2 branches. मगर this resistor current how many branches? 5 branches. Connections correspond this element are not identical. That's why this method cannot be applied. जो मेथड दिखा रहे हैं ना, this method cannot be applied. Write the note with your own statements. Okay, write the note with your own statements. Dear students, whenever you are copying the solution also, जिधर आपको थोड़ा confusion लग रहा है, immediately mention the note with your own statements. If you write the note with your own statements, advantage क्या है बोल तो रिविजन करते समय थोड़ा आसानी से समझ में आते हैं आपको. जो आपको कन्वीनियंट लैंग्वेज है, हिंदी, इंग्लिश और उर्दू, चाइनीज, जो आपको लैंग्वेज आते हैं वो लैंग्वेज में लिख लो. ओके. अब चेक करेंगे हाउ कैन यू सॉल्व दिस प्रॉब्लम. अब चेक करेंगे हाउ कैन यू सॉल्व दिस प्रॉब्लम. To solve this model of questions, we can go for the different approaches. One of the approach for this one is a perpendicular symmetry. Now for this particular example, corresponding example here with respect to AB points, where the AB points are indicated along the x-axis. This AB points are indicated along the x-axis. देखिए, in this example here, the AB points are indicated along the x-axis. Here the dotted lines are indicated along the y-axis. Then what is the angle for this particular example? What is the angle between the dotted line and AB points? Is exactly 90 degrees. The angle between the dotted lines and AB points is exactly 90. 90 means we can use word as a perpendicular. And for this particular example, देखो जी, with respect to dotted lines, this entire first portion and this entire second portion both are exactly identical. देखिए, if with respect to dotted lines, this entire part दोनों exactly identical बोलते हो आप क्या बोल सकते हैं? Symmetry. We can use word as perpendicular symmetry. Let us see what is the importance of this method. According to this perpendicular symmetry, whenever you are indicating dotted line, if any joints are present, we can name that one as the equipotential points. If any joints are there, we can name that one as the equipotential points. Now, in this example here, the point C is named as a equipotential points. The point C is a equipotential point. Here, equipotential point meaning क्या है बोले तो, at this point no current division is present. At this equipotential point no current division is present. उसका मीनिंग क्या है बोले तो, मान लो इधर 2 amperes current is coming here, entire 2 ampere go to this one only. Suppose if I current is coming here, entire I current go to this resistor only. At this equipotential point no current division is present. If no current division is there, then to make calculation simple, we can disconnect this equipotential point. In this example, that equipotential point should be disconnected along the dotted lines. देखिए dotted lines कैसे दिखा रही इधर? Along the which axis है? Y axis. Dotted lines किधर दिखा रही है? Along the y axis. This equipotential point is disconnected along the dotted lines. If you disconnect along the dotted lines, now corresponds example here with respect to dotted lines. Here, what is the name of this method? The equipotential point is disconnected. It should be disconnected every time along the dotted lines. Once again, I'll repeat here. Then after we have to write the note with your own statements. देखिए, in this example, AB points are present along the x-axis. Dotted line indicate along the y-axis. Angle कितना है इधर? Dotted line and AB points में exactly 90 बोलते perpendicular. Okay. And आप इधर dotted line से देखें तो with respect to dotted lines, this entire part both are exactly identical. बोलते हो, we can use word as a symmetry. And whenever you are indicating dotted line, if any joints are there, we can name this one as a equipotential point. Now every time this equipotential point is a, at the meaning of equipotential point is a, at this point no current division is a present, and every time it should be disconnected, it disconnected along the dotted lines, disconnect along the dotted lines. Can you write the note with your own statements? For this one also derivations are there, no need of any derivations, just remember the procedure. Can you write the note with your own statements पहले, बाद में सिंप्लीफाई करेंगे. सचिन स्टेटमेंट आप बोल दीजिए क्या सचिन जी. ओके डोंट वरी, आई डिक्टेट, लिख लो. डोंट वरी, डिक्टेट, नोट लिख लो. Write the note. In the above network, note लिख लो जी. Somebody requesting note के लिए, don't worry, I'll dictate. In the above network, AB points are indicated. AB points are indicated along the x-axis. AB points are indicated along the x-axis. And dotted line is indicated along the, and the dotted line indicated along the y-axis, and the dotted line indicated along the y-axis. Dot line indicated along the y-axis. In the brackets write perpendicular. In the brackets write perpendicular. Come on. With respect to dotted lines, network is symmetry. With respect to dotted lines, given network is symmetry. Symmetry. Next point. In the dotted line, if any joints are present, then it is known as, equipotential point. Then it is known as equipotential point. In the brackets write, at equipotential point, no current division is present. At equipotential point, no current division is present. At equipotential point, no current division is present. Next point. Equipotential point is a disconnected. Equipotential point is a disconnected along the dotted line. Equipotential point is disconnected along the dotted line. देखिए, in this example, how the R and R both are connected? Series. The series combination connected parallel to this R. How this R and R both are connected? Series. This series combination connected parallel to the R. Can you simplify this one? In this example here, 2R and R both are in the parallel. What do you write this way? 2R by 3. This R and R both are in series. Equivalent value is a 2R. ऐसे दिखा सकते ना, देखिए 2R and R both are in the parallel, what do you write this with 2R by 3, R and R both are in series 2R. अब बोलिए सिंप्लीफाई कर सकते ना, देखिए ब्रांच 1, ब्रांच 2, ब्रांच 3, तीनों ब्रांचेस कैसे है इधर पैरेलल है ना, तीनों ब्रांच कैसे है पैरेलल है ना, कैन यू सिंप्लीफाई कर सकते हैं आप, branch 1, branch 2, branch 3, all the branches are in the parallel, all the branches in the parallel. Can you find out the equivalent resistance with respect to A and B? सिंप्लीफाई करो जी, सिंप्लीफाई करने से कैन यू गेट द इक्विवेलेंट रेजिस्टेंस विद रिस्पेक्ट टू A and B? Okay, very good, very good. Many students are saying 4R by 5. Is it correct? Many students are saying 4R by 5. Very good, very good. Okay. Very good, very good, very good. Now observe here. Again the same problem we can solve by using other approach. Again the same network I am taking. The same network I am taking. Now to solve this one, we can go for one more method. To solve this type of complex network also, we can go for so many methods. But if you prefer these methods, you can save the time in the objective questions. केवल the objective questions में आपका हमेशा target in the less time we need the accurate answer. That's why to explain these equivalent resistance problems also from the previous papers I have taken some typical questions. And one more thing, whenever you are doing the revision, all these equivalent resistance problems, initially you may find little difficulty. Don't worry, don't lose the confidence. Don't expect the 100% output in the first revision itself. That once again I am stressing that one. धीरे धीरे revision करने से आपको everything will be cleared. Don't worry. देखिए, let us see the one more approach. इधर और एक approach क्या है बोले तो देखिए, now one more approach for this parallel symmetry. और एक approach क्या है बोलते parallel symmetry. देखिए, with respect to AB points, इधर AB point किधर है जी x axis. इधर AB point किधर है जी x axis. इधर ऐसे बोल सकते ना, with respect to AB points, this upper one and lower one both are exactly identical. इधर कैसे हो रहा है जी, with respect to this AB points, this upper one and lower one both are exactly identical. Exactly identical, exactly identical बोलते क्या बोल सकते हैं इधर, symmetry. Exactly identical बोलते क्या बोल सकते हैं इधर, symmetry. Now statement क्या है इधर, parallel. Now आपको AB points किधर है, x axis. AB points are along the x axis. But the dotted line also indicate along the x axis. The AB points किधर है, x axis. Dotted line also indicate along the x axis. That means what is the angle? What is the angle with the dotted lines? Dotted lines in AB is a 0. Angle with the dotted lines in AB 0. That means we can use what as a parallel. We can use what as a parallel. That means parallel symmetry. Parallel symmetry. Okay. Chaliye, let us see how can you solve the problem by using parallel symmetry. With respect to parallel symmetry, simply we use this technique. Simply we apply the folding technique. Folding technique बोलता हूँ, see, the lower part of the network is folded to upwards. The lower part of the network is folded to upwards. Whenever you are folding this one to upwards, each element becomes to the parallel to the other element. देखिए, this element and this element becomes a parallel. This element becomes a parallel. This entire branch come to the parallel to this one. Similarly, this element and this element becomes a parallel. This one becomes a parallel. क्यों बोलते, we are folding lower part of the network to upwards. We are folding lower part of the network to upwards. When you fold this one upwards, when you fold this one is upwards, we can indicate like this. Now for this example, when you fold this one upwards, we can write this as R by 2. R by 2. Can we draw this, sir? We can fold this one to upwards. We can fold this one to upwards. If you fold this one upwards, sir, we can draw like this. And further, we can simplify by using any method. Okay. Once again, I will repeat entire procedure. देखिए इधर AB present along the x-axis. Dotted line also indicate along the x-axis. With respect to dotted lines, upper one and lower one both are exactly identical. Identical बोल तो we can use what as a symmetry. कौन सा symmetry? Parallel symmetry. क्यों बोलते कि angle कितना है जी? Angle with the dotted lines in AB is a 0. Parallel symmetry. इधर और एक statement क्या है? We are applying the folding technique. We are folding lower part of the network to upwards. We are folding lower part of the network to upwards. If you fold this one upwards, sir, you obtain network like this. We get the network like this. Okay. Now write the note here. एक note लिख लो इधर. Write the note. First point. In the above network, Krishi Sharma, थोड़ा ध्यान से सुनो जी, ऑलरेडी कंक्लूडेड दैट I by 3 मेथड कैनॉट बी अप्लाइड. क्यों बोलते, कनेक्शंस आर नॉट आइडेंटिकल. थोड़ा ध्यान से सुनो स्टेटमेंट्स. इन द एबो नेटवर्क, AB points are indicated. This AB points are indicated along the x-axis. Along the x-axis. And dotted line also indicated. And dotted line also indicated along the x-axis. Dotted line also indicated along the x-axis. And with respect to dotted lines, network is symmetry. Network is symmetry. In the brackets write parallel symmetry. The brackets write parallel symmetry. Next point. Okay. Next point. In this method, in this method by applying folding technique. By applying folding technique, lower part of the network folded to upwards. Lower part of the network is folded to upwards. Lower part of the network is folded to upwards. Thereby each element becomes a parallel to other element. Each element becomes a parallel to other element. Okay. I folded this one upwards. देखो जी, by folding upwards, finally we got like this. Folding करने से we got this expression. देखिए, then after here again you can go for any approach, but I am going for the perpendicular symmetry concept. Your AB points किधर है जी? Along the x-axis. Now let us name this point as a C. Now these dotted lines are indicated. Dotted lines indicate along the y-axis. AB along the y-axis, AB along the x-axis, dotted line along the y-axis. Now here the C is a equipotential point. The C indicate the equipotential point. Previously I already concluded with respect dotted lines here, this part and this part both are exactly identical. बोल तो we are going for which one here? Perpendicular symmetry. We are going for the perpendicular symmetry. Previously concluded with respect to perpendicular symmetry, whenever you are indicating dotted line, if any joints are there, we name that one as a equipotential point. I conclude one more statement also. Every time this equipotential point is disconnected along the dotted lines. Every time this equipotential point is disconnected along the dotted lines. It is disconnected along the dotted lines. For this one, how do we write this with the R? Every time it is disconnected along the dotted lines. Can you write like this? Simplify further. Further simplify करो जी. R/2 दोनों कैसा है इधर? Series. There R and R दोनों कैसे इधर? Series. This series combination connected parallel to R/2. देखो जी, this series combination connected parallel to R/2. अब simplify करो. Find the equivalent resistance with respect to A and B. Simplify करके find out करो जी. Okay. वैभव राज, फोल्डिंग टेक्निक कब लगाते जी? पैरेलल में लगाते हैं, परपेंडिकुलर सिमेट्री में नहीं. पैरेलल सिमेट्री में लगाते फोल्डिंग टेक्निक, परपेंडिकुलर सिमेट्री में नहीं. ओके वैभव राज, स्टेप 2 क्या कर रहे हैं? परपेंडिकुलर सिमेट्री लगा रहे, पैरेलल सिमेट्री नहीं. पैरेलल सिमेट्री स्टेप 1 में हो गया. अब चेक करो जी वेदर आंसर इज सेम और डिफरेंट. फर्दर सिंप्लीफिकेशन आप कर सकते हैं ना. सिंप्लीफाई करो. सिंप्लीफाई करने से कैन यू फाइंड आउट द इक्विवेलेंट रेजिस्टेंस विद रेस्पेक्ट ए एंड बी? सिंप्लीफाई करो जी. हियर आल्सो आंसर सेम और डिफरेंट. चेक करो. 4r/5. There will be answer same, 4r/5. Very good, very good, very good, very good. Okay. Okay, let us see one previous paper question. Just open the workbook. Open the workbook. Read this question number 41. In the first unit, read the question number 41. वर्कबुक ओपन करो जी. वर्कबुक ओपन करके गो टू द क्वेश्चन नंबर 41 देखिए एक बार. इन द यूनिट 1 में 41 देखिए एक बार. क्वेश्चन नंबर 41. Okay. देखो जी. In this example, where the AB present along the y-axis, AB carries the y-axis. Now I am trying to indicate the dotted line. I am trying to indicate the dotted line along the x-axis. AB carries the y-axis. Dotted line carries the x-axis. इधर एंगल कितना है जी? डॉट लाइन AB is exactly 90. 90 बोल तो क्या बोल सकते हैं इधर? परपेंडिकुलर. क्या बोल सकते हैं इधर? परपेंडिकुलर सिमेट्री. Perpendicular symmetry. According to this perpendicular symmetry, if any joints are present, we can name that one as the equipotential points. If any joints are there, we can name that one as the equipotential points. We can name that one as a equipotential points. Here C and D are the equipotential points. Here C and D are the equipotential points. Then what is the current of this branch? In this example, if equipotential points are there, then what is the current of this one equal to 0. इधर कोई भी मेथड लगा सकते हैं आप. कभी भी इक्विपोटेंशियल पॉइंट है तो दो तरह का मेथड्स है. एक मेथड क्या है, इधर C and D को शॉर्ट सर्किट कर सकते हैं, और एक मेथड क्या है इधर ओपन सर्किट. आप कोई भी मेथड प्रेफर कर सकते हैं. You can go for either open circuit or the short circuit. कोई भी मेथड अप्लाई कर सकते हैं. Now for this particular example, I am going for the open circuit. थोड़ा कॉमन सेंस यूज करिए आप. कौन सा मेथड से आसानी से बोल सकते हैं, ओपन सर्किट और शॉर्ट सर्किट. देखिए आप इधर कनेक्शन चेक करें तो आप इधर ओपन सर्किट करें तो आसानी से बोल सकते हैं हाउ द रेजिस्टेंस बोथ आर कनेक्टेड इन द सीरीज. आप इधर ओपन सर्किट तो हाउ द R and R both are connected in the series. R and R both are connected to the series. Can you draw the simplified figure for this one? Can you draw the simplified figure for this one? Can you draw the figure like this? क्या चाहिए आपको? We need the equivalent resistance with respect to A and the B. A and B. देखो जी इधर पोटेंशियल डिफरेंस कितना है इधर? 0 बोलते हो. कैन यू ओपन सर्किट दिस वन? कैन यू ओपन सर्किट दिस पोर्शन? आप कोई भी इधर लगा सकते हैं. होना बोलते हो शॉर्ट सर्किट भी कर लो आप, मगर थोड़ा ओपन सर्किट करें तो आंसर आसानी से बोल सकते हैं. ओके. कैन यू डू द फर्दर सिंप्लीफिकेशन आप कर सकते हैं ना. देखो इधर हाउ दिस R and R both are connected सीरीज. इधर भी देखिए हाउ दिस R and R both are connected series. How the R and R both are connected series. Can you develop the simplified figure for this one? Can you develop the respective simplified figure? इधर कितना है इधर R. देखिए R R and R both are in series, 2R. How the 2R and R both are connected? Parallel. 2 and R both are in the parallel. What will reduce with 2R by 3? Again, how this R and R both are connected? Series, 2R. Can you find out the equivalent resistance? Okay, 2R and R both are in the parallel. What will reduce the 2R by 3? For this example here, this branch 1, entire branch 2, entire branch 3, all the branches are connected in the parallel. For this example, the branch 1, branch 3, all the branches are connected in the parallel. All the branches are connected in the parallel. Can you find out the equivalent resistance for this one? Check Karoji, I give all the hints. Dhruv, yes, we can go for star delta also, but it become little lengthy. कर सकते जी, स्टार डेल्टा भी कर सकते हैं. You can, it become little lengthy. क्यों? मतलब ऑब्जेक्टिव क्वेश्चन में आपका टारगेट कम समय में एक्यूरेट आंसर चाहिए. ओके, आपको ये मेथड डिफिकल्ट लग रहा बोलते हो, गो फॉर स्टार डेल्टा ट्रांसफॉर्मेशन. चॉइस इज योर्स. ओके, चेक करो जी. हाँ, मेनी स्टूडेंट्स आर सेइंग 8R by 15. 8R by 15. क्वेश्चन में रेजिस्टेंस वाले कुछ दिया इधर. चेक करो, रेजिस्टेंस इक्वल टू 1, इधर R इक्वल टू 1. R इक्वल टू 1 बोलते हो, आंसर कितना है इधर? 8 by 15. इधर R इक्वल टू 1 बोलते हो, क्या बोल सकते हैं? 8 by 15. Okay. Okay. Later can you apply your own ideas for this 59 also? बाद में चेक कर लो. वर्कबुक में और एक मॉडल है, जस्ट अप्लाई योर आइडियाज फॉर दिस वन. चेक कर लो, 59 भी चेक कर लो. तर आसानी से कंक्लूड करने के लिए वी कैन गो फॉर द परपेंडिकुलर सिमेट्री. बाद में आप चेक कर लो, सेम कॉन्सेप्ट यू कैन अप्लाई. ओके, dear students, already concluded. Correspond to workbook, what I will do at the end of the first unit, I will try to provide complete workbook solutions. I will provide a soft copy for that one. But in my discussions, what I will do in the workbook, I will try to discuss all the typical questions. The easy questions I won't discuss. That's what I am doing. I will try to provide complete workbook solutions. I will provide a soft copy for that one. But at the end of the first unit, I will provide that one. Okay? First unit होने के बाद I will provide that one. Next put side heading KCL. Now if you come to KCL, the KCL works from the principle of law of conservation of charge. Law of conservation of charge. Now for this particular example, here, this I1 is coming toward the node. I1 is the incoming current, but the I2 also incoming current, but the I3 is the outgoing current. I4, now with respect to KCL, algebraic sum of the currents with respect to KCl, algebraic sum of the currents meeting at a point equal to 0. Algebraic sum of the currents meeting at a point equal to 0. In this example here, few currents are coming toward the node, few currents are going away from the node. इधर करंट बोलते क्या है जी? फ्लो ऑफ इलेक्ट्रॉन्स. फ्लो ऑफ इलेक्ट्रॉन्स बोलते क्या है? चार्ज. That means how many electrons are entering at node? Same number of electrons leave from the node. Same number of electrons leave from the node. In that way, we are using word. It is works from the principle of law of conservation of the charge. Again, come to the node. Here, all the branches in this example, 6 branches are connected at one common point. This common point is named as a node. Common point named as a node. Again, if you come to node also, if you come to this node also, two types of nodes are present. Nodes also, two types of nodes are present. One is a simple node, other one is a principal node. One is a simple node, other one is a principal node. Let us see what is the difference between the simple node and the principal node. For this example, if two elements are connected together, then the common point is named as a simple node. कभी भी two terminals connect हुआ तो जो common point रहते हैं ना, common point is named as a simple node. When two terminals are connected together, the common point को क्या बोल सकते हैं इधर? Simple node. कभी भी two terminals connect हुआ तो the common point is a simple node. Common point क्या है इधर? Simple node. और एक statement क्या है इधर? Principal node. If more than two elements are connected together, then the common point is known as a principal node. If more than two elements are connected together, then the common point is nothing but a principal node. Common point is a principal node. कभी कभी क्वेश्चन में क्या करते हैं? Simply they give the figure. They ask you to identify how many nodes are there in the given network. क्वेश्चन में कुछ भी स्पेसिफाई नहीं करते. Simply they give statement how many nodes are there in the given network. तब क्या करना है बोलते हो? दोनों को इंक्लूड करना है. सिंपल नोड एंड प्रिंसिपल नोड दोनों को इंक्लूड करना है. सिंपल नोड एंड द प्रिंसिपल नोड. देखिए एग्जाम्पल में कितना है जी? फॉर दिस एग्जाम्पल में सिंपल नोड्स कितने इधर? सिंपल नोड्स आर दी 3. नो प्रिंसिपल नोड्स कितने इधर? 2. दैट मीन्स टोटल हाउ मेनी नोड्स? फॉर दिस पर्टिकुलर एग्जाम्पल टोटल हाउ मेनी नोड्स आर देयर? 5. फॉर दिस एग्जाम्पल टोटल हाउ मेनी नोड्स आर देयर? 5. देखिए कम टू द नेक्स्ट वन. अगेन कम टू द नेक्स्ट पॉइंट. For this particular example, again the branches. Either branches be two types of branches are there. Here also two types of branches are there. One is a simple branch, other one is the independent path. One is a simple branch, other one is the independent path. चलो चेक करेंगे. What is a simple branch, other one is the independent path. इधर simple branch बोल दो every element. Simple branch meaning क्या है बोल दो? Every element. जो सिंपल ब्रांच है ना, सिंपल ब्रांच बोलते हो एवरी एलिमेंट इज टेकन एज ए वन सिंपल ब्रांच. दैट मीन्स सर ईच एलिमेंट इज टेकन एज ए वन सिंपल ब्रांच. ईच एलिमेंट इज टेकन एज ए वन सिंपल ब्रांच. अब देखो जी फॉर दिस एग्जाम्पल हाउ मेनी सिंपल ब्रांच आर देयर? देखिए इधर सिंपल ब्रांच 1 2 3 4 5 6. टोटल कितना है जी? टोटल हाउ मेनी सिंपल ब्रांचेस आर देयर? 6 सिंपल ब्रांचेस. और एक क्या चाहिए आपको? इंडिपेंडेंट पाथ. इधर देखो जी फॉर दिस एग्जांपल दिस A to B, other one C to D, what is the other one? E to F. इधर देखो जी दिस एंटायर A to B इज वन इंडिपेंडेंट पाथ. इसका मीनिंग क्या है बोलते हो? मान लो इधर सोर्स करंट इज डिलीवरिंग ए करंट ऑफ द IT. This IT current distributed as a give the name says some I1 and I2 currents. इधर देखो जी in this entire AB current क्या है इधर? IT. Similarly in this entire CD current कितना इधर? I1. In this entire E and F current कितना इधर? I2. That means either how many independent paths are there? 3 independent paths. One is the AB, other one CD, other one is the E and F. Either independent path बोले तो in that path only one current has to be circulated. इधर कौन सा करंट सर्कुलेट हो रहा है जी, IT करंट. इधर कौन सा करंट जा रहा है, इधर I1 करंट. इधर कौन सा करंट जा रहा है, इधर ओनली I2 करंट. That means sir, for this particular example, how many independent paths are there? First, can you conclude how many simple branches are there? 6. How many independent paths are there? 3. Now for that independent paths also we give the names. For the independent paths also we give the names. नाम क्या है इधर? A, B, C, D. Other one क्या है इधर? E and F. Other one क्या है इधर? E and F. These are the independent paths. Independent paths. पहले फिगर्स कॉपी कर लो जी. पहले फिगर्स कॉपी कर लो. First note of the figures. I'll dictate some points. Yes, Anu Kumari. That is the verb question only. Verb question only. Anu Kumari, yes. कौन सा वॉल्यूम की वर्क बुक? कौन सा वॉल्यूम है जी? एक ही वॉल्यूम है. अपना नेटवर्क एनालिसिस डाउनलोड नहीं किया है आप? अपना नेटवर्क एनालिसिस जी, कौन सा चैप्टर चल रहा है वो भी नहीं पता है आपको. और नेटवर्क एनालिसिस चैप्टर 1 का क्वेश्चन होमवर्क दिया आपको 59 बोले तो. क्या खुशी शर्मा, अभी तक आप वर्क बुक भी डाउनलोड नहीं किया? क्या कर रहे जी इतना दिन? अब सब लोग PDF मिल गए होंगे ना? PDF, अदरवाइज यू माइट हैव रिसीव्ड द हार्ड कॉपीज अदरवाइज. थोड़ा देख लो वर्क बुक क्या है, कौन सा बुक्स मिल गए आपको, पहले वो भी देख लो जी. उतना बिजी है क्या आप? यस भावना, करेक्ट भावना. Okay, just indicate this one. सिंपल ब्रांचेस कितने हैं इधर? 3. और फिगर में, गिवन फिगर में सिंपल नोट्स कितने हैं इधर? 3. प्रिंसिपल नोट्स आर द 2. ये भी दिखा दो. डिजिटल नोट्स क्या है जी? ये डिजिटल नोट्स क्या है? यस, नेटवर्क्स वॉल्यूम 1 में है. अभी तक वॉल्यूम 1 में कौन सब्जेक्ट्स हैं वो भी नहीं देखे. फॉर दैट क्वेश्चन नंबर 59 आंसर इज 100 ohms. Okay, in that volume 1, in the volume 1 networks workbook है. Okay, फर्स्ट यूनिट होने के बाद आई विल प्रोवाइड कंप्लीट वर्कबुक सॉल्यूशन. सॉफ्ट कॉपी प्रोवाइड करूंगा आपको, डोंट वरी. ओके, डोंट वरी खुशी सिंह जी, डोंट वरी. Cool. Write some points. When the two elements are connected together, then the common point is known as simple node. Simple node. Next point. When more than two elements are connected together, then when more than two elements are connected together, then the common point is known as, when more than two elements are connected together, then the common point is known as principal node. Common point is known as principal node. Common point is known as principal node. Okay. Come to the next one. देखिए इधर. Again, while solve the problems, to make calculation simple, every time we use the current division technique. इधर current division technique बोले तो we write the branch current in terms of total current. The current division technique बोले तो we write the branch current in terms of total current. इधर कैसे लिख सकते हैं? इधर we write इसमें I1 equal to total current. I1 equal to total current into opposite resistor. देखिए इसका opposite resistor क्या है? इधर R2 by total resistance R1 plus R2. Come to the I2. I2 equal to total current into same procedure, opposite resistor क्या है इधर? R1 by total resistance R1 plus R2. Every time remember as the procedure what you are applying for resistors, the same logic you can apply for the inductors. जो procedure resistor के लिए लगा रहे, the same logic you can apply for the inductors. हमेशा resistors, inductors, impedances के लिए the same logic you can apply कर सकते. Okay? Inductors के लिए भी same logic. Opposite inductance में total inductance. Okay, somebody asking previous example. देखिए इधर सिंपल ब्रांचेस कितने हैं जी? 6 ऑलरेडी कंक्लूडेड. इंडिपेंडेंट पाथ्स भी दिखा है ना आपको. कितना है इंडिपेंडेंट पाथ्स? कितने हैं इधर? 3. टोटल नोड्स कितने हैं इधर? 5. ओके. Now come to capacitors. Now correspond capacitors, sir. Again, can you apply the current division technique? Now I1 equal total current. Now total current into similar capacitance. There similar capacitance क्या है जी? C1 by C1 plus C2. Now total current into similar capacitance. Similar capacitance कितना है इधर? C2. C1 plus C2. Okay. And one more thing, in your workbook this question number same or different? Somebody is saying the question number is different. एक बार चेक करो जी, आपका वर्कबुक में चेक करो एक बार. In your workbook also for this question चेक कर लो एक बार, क्वेश्चन नंबर 41 is same or different? Please give reply. In your workbook, that question number is same or different? Somebody is saying question अलग है. गौतम कुमार जी, आपको क्या चाहिए? Anybody give reply? दिस क्वेश्चन नंबर सेम ना? क्या आपका वर्कबुक में अलग है क्या नंबर? एक बार चेक कर लो. ओके, somebody asked in the previous slide. हमेशा जो रेसिंग के लिए प्रोविजर लगाते हैं, सेम प्रोविजर फॉर द इंडक्टर्स. ओ, सब सेम बोल रहे हैं क्या? सिंह जी, खुशी सिंह जी, आप अलग ही बोल रहे हैं, बट रिमेनिंग स्टूडेंट्स आर सेइंग सेम. ओके ओके, डोंट वरी. कुछ गड़बड़ हो गए होंगे उनको, डोंट वरी. यूनिट 1 में नेटवर्क्स में देखो, आई थिंक आई होप यू माइट हैव सीन इन द अदर चार्ट्स में देखे होंगे आप अपना नेटवर्क एनालिसिस में. यूनिट 1 में क्वेश्चन नंबर 41. ओके, डोंट वरी. देखिए, इन दिस एग्जांपल हाउ मेनी रेजिस्टर्स वी सेलेक्टेड? ओनली 2 रेजिस्टर्स आर इन द पैरेलल. बट इन द क्वेश्चंस दे मेक यू लाइक दिस. कभी कभी क्या होता है क्वेश्चंस में, दे मेक यू लाइक दिस. इट मे हैव द n number of branches. If it is n number of branches, I1 equal to कितना total current is the I. We can write this as a reciprocal of similar resistance. कितना is similar resistance? R1. In the denominator, sum of the reciprocal values. Sum of the reciprocal values. Reciprocal of the similar resistance in the denominator, sum of the reciprocal values. Whenever the more number of branches are there, to conclude the answer, go for this approach. होना बोलते सेम मेथड आप 2 रेजिस्टर की भी लगा सकते हैं. चेक कर लो by simplifying that one. होना बोलते for 2 resistors also we can apply same logic. इधर क्या लिख सकते हैं? इधर होना बोलते ऐसे लिख सकते हैं, I1 equal total current into reciprocal of similar resistance. In the denominator, sum of the reciprocal values. आप इधर सिंप्लीफाई करें तो you get the same answer. होना बोलता चेक कर लो आप. Okay. Now in the questions what they do here, in place of resistance, they may give the data in terms of conductance. देखिए, the reciprocal of resistance क्या है इधर? conductance G1, G2 up to क्या है इधर? Gn, n number of branches. In the questions what they do here, in place of resistance they may give the data in terms of conductance. सब ब्रांचेस के लिए सेम है जी. इंस्ट्रूमेंटेशन के लिए, इलेक्ट्रॉनिक्स के लिए और इलेक्ट्रिकल के लिए अपना नेटवर्क्स का वर्कबुक सेम ही है. देयर इज नो डिफरेंस इन द वर्कबुक. ओके, और कुछ डाउट्स? For all the branches questions work is same. And one more thing, थोड़ा this year workbook है modified. Last year workbook different, this year workbook is different. This year workbook में added some few questions. Last year workbook अलग है जी, ये साल का workbook अलग है. ये साल में थोड़ा कुछ questions add किए मैं. I updated workbook this year. Okay. सब ब्रांचेस का सेम है, मगर दिस ईयर आई अपडेटेड द वर्कबुक, एडेड सम न्यू क्वेश्चंस. ओके जी. चलिए नाउ राइट दिस क्वेश्चन. एक क्वेश्चन लिखो जी. फाइंड आई नॉट ऑफ द नेटवर्क शोन. फाइंड आई नॉट ऑफ द नेटवर्क शोन. Find I naught of the network shown. Find I naught of the network shown. चेक करो जी. इस एग्जाम्पल कैन वेरीफाई दिस फिगर एंड दिस फिगर. एक बार चेक करो. दिस फिगर बोथ आर सेम और डिफरेंट. चेक करो एक बार. दिस फिगर बोथ आर दी सेम. बोथ फिगर्स आर दी सेम. नाउ लेट अस सिंप्लीफाई दिस वन. अब सिंप्लीफाई करेंगे. फॉर दिस एग्जाम्पल हाउ द 6 and 3 बोथ आर कनेक्टेड पैरेलल. Again here also how the 2 and 2 both are connected to the parallel. 6 and 3 in the parallel. Equivalent resistance कितना इधर 2 ohms. 2 and 2 both are in the parallel. Equivalent resistance कितना इधर 1. Equivalent resistance is 1. Can you find out the total current? I equal to voltage कितना है 27. 2 plus 1. आप इधर simplify करें तो कितना है total current equal to 9 amperes. This total current equal to 9 amperes. These two are in the parallel 2, these two are in the parallel 1. 27 by 3, 9 amperes. Can you find out the current of each branch? Can you find the current of each branch? Let us assume current is I6 and the other one is the I3. I6 and I3. To find the current of each branch, can you go for current division technique? If you apply current division technique, देखिए इधर दोनों branches के लिए total current कितना है इधर 9. ऑपोजिट रेजिस्टर. नो ऑपोजिट रेजिस्टर कितना है इधर 3. आप इधर सिंप्लीफाई करें तो 3 एम्पियर्स. कम टू I3 इधर 6 एम्पियर्स. नो फॉर दिस एग्जांपल इधर करंट कितना है जी 3 एम्पियर्स. करंट कितना है इधर 6 एम्पियर्स. फॉर दिस एग्जांपल 3 एम्पियर्स इज कमिंग, 6 एम्पियर्स आल्सो कमिंग. 3 amperes coming, 6 amperes coming. Total current कितना इधर 9. Total current कितना इधर 9. How the 9 ampere distribute the two branches? How the 9 ampere distribute the two branches? Then what the current of each branch? 4.5. What is the total current? How much here? 3 plus 6, 9. How the 9 amperes is equally distributed the two branches. But the current of each branch is the 4.5 and the 4.5. Can you get these currents? Okay. Three amperes, 6 amperes, 4.5. 9 amperes. Apply the KCL at this point. If you apply KCL at this point, what about the 6 is the incoming? 6 incoming. What about this I0 is also incoming? 4.5 is the outgoing. In this example here 6 incoming, I0 incoming, 4.5 is outgoing. आप इधर सिंप्लीफाई करें तो सिंप्लीफाई कैसे लिख सकते हैं इधर I0 इक्वल टू -1.5, I0 इक्वल टू -1.5. Okay. By applying current division technique, first try to find the current of each branch. जो करंट से इधर आए ना 3.6 इधर इंडिकेट करिए 4.5 इंडिकेट द रेस्पेक्ट टू करंट्स. बाद में क्या करो, अप्लाई द केसीएल एट दिस पॉइंट. 6 क्या है जी इनकमिंग करंट, I0 क्या है इनकमिंग करंट, 4.5 आउटगोइंग. सिंप्लीफाई करने से यू गेट द -1.5. वेरी गुड. मेनी स्टूडेंट्स गिव रिप्लाई. वेरी गुड, वेरी गुड. Right, the next one. Find V0 of the network shown. Find V0 of the network shown. फिर कौन सा नाम दिया जी खुशी शर्मा जी? नाम क्या दिया बोलिए, कुछ नाम बदल दिया क्या? Electrical students को generally it is named as a electric circuit. Electronics में they use the network theory, मगर अंदर कंटेंट सेम ही है. फॉर दिस एग्जाम्पल देखो जी, आपको इधर वोल्टेज पता है, रेजिस्टेंस पता है. वोल्टेज पता है, रेजिस्टेंस पता है. कितना है जी वोल्टेज 10, रेजिस्टेंस is 2. 10/2 means what? Current this one how much here? 5 amperes. Current is 5 amperes. The resistance nature क्या है जी? Absorbing power. Resistance nature क्या है जी? Absorbing power. Now absorbing power के लिए always what is the requirement? The current should be enter at the positive. The resistance nature क्या है? Absorbing power. Absorbing power के लिए the current should be enter at the positive. Current should be enter at the positive. Come to second one. The resistance कितना है इधर 3. Resistance कितना है 3. What is the voltage how much here? 12. Resistance 3, voltage 12. Current कितना है इधर? 12/3. 12/3 equal to what the current is how much? 4 amperes. Current how much here? 4 amperes. The resistance nature क्या है जी? Absorbing power. Absorbing power. Absorbing power के लिए current should be enter at the positive. Current should be enter at the positive. Here this entire N2 is one complex network. This entire N2 is one complex network. हमेशा स्टेटमेंट क्या है इधर? Always incoming current should be equal to outgoing currents. The statement क्या है जी? Always incoming current should be equal to outgoing currents. इधर कितना है जी? 5 is the incoming current, but the 4 is also incoming current. The statement क्या है जी? 5 is the incoming current, 4 is also incoming current. Always incoming current should be equal to outgoing currents. Incoming current should be equal to outgoing currents. कितना है जी outgoing current? कितना है इधर? 9 amperes. Now 5 is the incoming, 4 is also incoming. Always incoming current should be equal to outgoing currents. Now क्या चाहिए आपको? V0. क्या चाहिए आपको? V0. when the current enters negative terminal, sign for the current is taken as a negative. Sign for current is taken as negative. Resistance कितना है इधर 4. Then what the answer? Minus 36 volts. Minus 36 volts. Okay, थोड़ा इधर डायरेक्शन के ऊपर बहुत ध्यान रखिए. समझ रहे ना आपको? This entire N2 is one complex network. 5 is incoming, 4 is also incoming. Always incoming current should be called outgoing currents. कितना है जी? Minus 36. Very good, very good. Many students give a reply. लिख लो, नो प्रॉब्लम, लिख लो जी, धीरे धीरे लिख लो, डोंट वरी. Okay, complete now. Minus 36. Okay, very good. Right, the next one. Find source current. Find source current and source voltage. Find. Yes, Sachin, your statement correct. Direction, others already conclude na. Resistance nature क्या है? Absorbing power. Absorbing power. Absorbing बोल दो current should be enter at the positive. In that way, first two branches are indicated. Third branch का कैसा आ गया? KCL. Incoming current equal to outgoing current. Find the source current and source voltage. Find source current and source voltage of the network shown. Okay. अब चेक करो जी. नो फॉर दिस एग्जाम्पल देखिए, फॉर दिस एग्जाम्पल इधर वोल्टेज कितना है, इधर 2, रेजिस्टेंस कितना है, इधर 1. वोल्टेज टू रेजिस्टेंस 1, वोल्टेज टू रेजिस्टेंस 1, करंट कितना होता है जी? 2/1 कितना होता है? करंट इज 2 amperes. लेट अस नेम द करंट दिस में I डैश. करंट इज I डैश. मान लो करंट दिस में इज I. मान लो करंट दिस में इज I. In this example here, for this entire branch current कितना है जी? 2 amperes. क्या चाहिए आपको? I. Can you apply the current division technique? Can you apply the current division technique for this one? 2 amperes. To relate the I dash and I, can you go for current division technique? If you apply current division technique for this one, what do you write this way? I dash equal to total current. I dash equal to total current. Total current into opposite resistor. Total current opposite resistor. For this entire branch के लिए opposite resistance क्या है इधर? 6 by total resistance. Now for this example कितना है जी? I dash equal to 2. I dash equal to 2. Simplify करने से can you find out the respective I value? चेक करो जी. I equal to 3 amperes. check करो जी, I equal 3 ampere. Simply we apply the current division technique. We are applying the current division technique. Okay. Now I value आ गया आपको. This I value is down. Can you develop the simplified figure for this one? तो थोड़ा आसानी से समझने के लिए can you develop the simplified figure? In this example, how this 3 and 6, how the 3 and 6 both are in the parallel. Parallel both the equivalent resistance कितना है इधर 2 ohms. Now what about this is also 2 ohms, 4 ohms. What is the requirement is the source current. देखिए कैलकुलेशन से आ गए आपको. If you indicate this I value, simplify करने से कितना आ गया? I equal to how much? 3 amperes. कितना आ गया जी? I equal to 3 amperes. Now for this example, देखो जी how these 2 ohms and 2 ohms both are connected series. देखिए in this example how the 2 and 2 both are connected series. Can I select this sir? The resistance is entire branch, both are the same. तो कैसे बोल सकते हैं? Resistance is entire branch, both are the same. Now दोनों branches के लिए resistance same है. जब दोनों branches के लिए resistance same है तो current of the both branches also same. जब दोनों branches के लिए resistance same है तो current of the both branches also same. कितना है जी current? How much? 3 amperes. ये भी current कितना होता है? 3 amperes. Now for this entire branch current कितना है इधर? 3. इधर भी क्या होता है? 3 वो होता है. क्यों? मतलब resistance कितना है इधर? 4. It is also 4. Can you apply KCL at this point? Can you apply KCL at this point? If I apply KCL here, IS is the incoming current. 3 is outgoing. Simplify करने से what is IS equal to how much? 6 amperes. IS equal to 6 amperes. Come to the VS. इधर भी देखिए how these two 4 and 4 both are connected parallel. 4 and 4 both are in parallel. This entire combination connected series to 5. Can you find out equivalent resistance? What about equivalent resistance? How much here? 7. This entire 4 both are in the parallel. Equivalent resistance कितना है इधर? 2. How the 2 and 5 both are connected in the series? आपको इधर equivalent resistance पता है, source current पता है. Can you find out source voltage? कैसे लिख सकते हैं? Source voltage equal to IS into R equivalent. कितना है जी? IS वाले कितना है इधर? 6 into 7. 6, 7. What is VS equal to how much here? 42. VS equal to 42. Next one. प्रॉब्लम लिखो जी इधर. वेरी गुड, वेरी गुड, वेरी गुड. In this example, power dissipation in the 2 ohm resistance is given. Power dissipation in the 2 ohm resistance is given. What is the power dissipation? Power dissipation equal how much here? 12.5. कितना है जी power dissipation equal 12.5. Resistance nature क्या है? Always absorbing power. Absorbing power means shall I select this here? The current is entering at positive. Absorbing power बोलते current should be enter at the positive. Current is entering at positive. ऐसे लिख सकते हैं ना? We can write this with I square R2. I square R2. देखिए आपको इधर रेजिस्टेंस वैल्यू पता है कितना है? रेजिस्टेंस वैल्यू हाउ मच? 2. रेजिस्टेंस वैल्यू इज 2. आप इधर सिंप्लीफाई करने से देन व्हाट अबाउट I इक्वल हाउ मच? I equal how much here? 2.5. I equal how much? 2.5. Now let us find out the Vx. Vx equal to when the current enters at positive terminal, sign for the current is taken as a positive. When the current enters at positive terminal, sign for the current is taken as a positive. 2 into current कितना इधर? 2.5. Then what about the Vx equal how much? What is Vx equal 5 volts. Vx equal 5 volts. Then can you apply the KCL at this point? Corresponds example. Can you apply the KCL? If you apply KCL at this point, what about this? I is the incoming current. I is the incoming current. देखो जी. What about the KVX also incoming current? KVX also incoming current. What about the 5 amperes is the outgoing? ऐसा बोल सकते हैं ना? Sum of incoming currents equal sum of outgoing currents. देखिए आपको I वैल्यू पता है, Vx वैल्यू पता है. आपको I वैल्यू पता है, Vx वैल्यू पता है. सिंप्लीफाई करके K वैल्यू निकाल सकते हैं ना? Incoming current should be called outgoing currents. Simply we are using incoming current should be called outgoing currents. Okay, very good, very good. Many students got answers. कितना है जी? K equal 0.5. K equal 0.5. कंप्लीट ना, K equal 0.5. Now draw this figure. चेक करो जी, दिस VAB equal 6 volts. Find the VC minus VD. चेक करो जी एक बार. Now for this example, देखिए, with respect to AB points, voltage कितना है जी? 6 volts. With respect to AB points, what is the voltage? How much? 6 volts. देखिए, always the first point, that means first letter indicate with the positive sign, other one is a negative sign. First letter with the positive sign and other one is a negative sign. First letter positive sign, other one is a negative sign. आपको इधर वोल्टेज पता है, रेजिस्टेंस पता है, वोल्टेज पता है, रेजिस्टेंस पता है, करंट निकाल सकते हैं ना. 6/2 को करंट कितना है इधर? 3 एम्पियर्स. हमेशा फर्स्ट लेटर के लिए गिव द पॉजिटिव साइन, अदर वन इज द नेगेटिव साइन. आप डायरेक्शन चेक करेंगे. डायरेक्शन के लिए क्या करो? फोकस ऑन द रेजिस्टेंस वैल्यू. रेजिस्टेंस नेचर क्या है जी? एब्जॉर्बिंग पावर. द रेजिस्टेंस नेचर क्या है? एब्जॉर्बिंग पावर. एब्जॉर्बिंग पावर के लिए करंट शुड बी एंटर एट पॉजिटिव. Absorbing power के लिए current should be entered at the positive. Current should be entered at positive. Now here the 3 amperes current is coming here. 3 amperes current आ रही इधर. It distribute in all the branches. पूरा branches में distribute होता है इधर. For this example, 3 amperes current is coming here. It distribute in all the branches. Finally, how much current will come outside? 3 amperes. Corresponds example, 3 amperes coming here. It distribute in all the branches. Finally, how much current come outside here? 3 amperes. आप इधर KCL अप्लाई करें तो कैसे लिखते हैं इधर? 2 is incoming, 3 is incoming. But current this one how much? 5 amperes. करंट कितना है जी? 5 amperes. करंट कितना है इधर? 5 amperes. Wherever the current is entering, that is positive, other one is a negative. जिधर करंट एंटर हो रहा है, that is a positive, other one is a negative. Here the current 5 amperes, resistance the 1, voltage कितना है जी? 5 volts. Wherever the current is entering, that is positive, other one is a negative. Now क्या चाहिए आपको? Potential difference between the C and the D. क्या चाहिए आपको? Potential difference between the C and the D. Potential difference between C and the D. Between C and D, potential difference कितना है इधर? 5 volts. मगर इधर ध्यान से देखना, इधर C के लिए कौन सा टर्मिनल कनेक्टेड है जी? नेगेटिव टर्मिनल. इधर C के लिए कौन सा टर्मिनल कनेक्टेड है? नेगेटिव टर्मिनल. फिर कैसे लिख सकते हैं? VC minus VD equal to -5 volts. कैसा लिख सकते हैं इधर, VC माइनस VD इक्वल -5 वोल्ट्स। थोड़ा पोलैरिटीज के ऊपर ध्यान रखना इधर। फॉर दिस पर्टिकुलर एग्जांपल देखिए, दिस एंटायर नेटवर्क जो है ना, this entire network will influence the calculation, does not influence. In objective questions what they do, to divert your attention they provide some additional data also. इधर एक क्वेश्चन सॉल्व करने के लिए आपको दिस एडिशनल डेटा इज नॉट रिक्वायर्ड, ओनली विथ हेल्प ऑफ द KCL, इनकमिंग करंट इक्वल आउटगोइंग करंट। वो कॉन्सेप्ट्स अप्लाई करने से वी कैन फाइंड आउट द पोटेंशियल डिफरेंस बिटवीन द C and the D, C and D. Okay. Okay dear students, with this one today's class completed. Okay, tomorrow also class timings are same.